passing the CCA isn't about the most powerful Claude feature. It's about choosing the safest production design under pressure. The wrong answer often looks impressive. More agents, broader tools, larger prompts, faster automation. The right answer is quieter. It narrows authority and defines success clearly. It proves behavior through evidence. Every model action is an architectural decision, and it must survive real users and real failure modes. The exam is not a usage quiz. Modern Claude systems aren't judged on one good response. They're judged on predictable behavior under stress. When tools fail, ambiguity increases and context ages. When business risk goes up, reliability matters most. A perfect prompt can't fix an unsafe system boundary, especially when real data, trust, and irreversible actions are at stake. Most wrong answers assume intelligence replaces architecture. That assumption fails in real-world production environments. Agents still need scope tools and retry policies. They require state control and audit trails for accountability. They also need eval coverage to ensure reliability. Without these structures, autonomy becomes uncontrolled. The exam penalizes confusing capability with readiness. Impressive reasoning remains dangerous without guardrails. Human review and rollback thinking are essential safeguards. The first wrong answer is agent inflation. Candidates see a complex workflow and add more agents. Agents are not magic workers. Each handoff adds latency and coordination cost. Context loss and permission risk increase too. A single loop with clear state can beat a swarm. When the task is narrow and sequential, easy to verify with deterministic checks, simple ownership across every step. The second trap is permission blindness. Tool access is not just an implementation detail, it defines the security perimeter. A tool reading invoices must be limited. One updating CRM records needs clear scope. A tool executing code requires strict approval. The safest approach avoids full access. Grant only the minimum necessary actions. Then log every action taken. Review all outcomes regularly. Limit what can happen next. The third wrong answer is skipping evaluations. A system that feels correct in a demo can fail silently in edge cases. Evils turn confidence into evidence. They define success criteria. They encode representative cases. They compare different prompt versions. They expose regressions. Without evals, every improvement is just a story. It's a story the team wants to believe, not a measured production claim, not something that can be defended. The fourth trap is prompt absolutism. Better instructions help, but not every failure is prompt shaped. Latency may require model choice or caching. Cost may require batching or context pruning. Hallucination may require retrieval, validation, or refusal rules. The CCA rewards diagnosis first, not reflexively adding another paragraph to the system prompt and calling it architecture after the fact under pressure. Ignoring structured output is the fifth mistake. Free-form answers feel natural for humans, but they're fragile when processed by software. Production workflows require clear schemas. They need nullable fields and validation rules. Repair loops and explicit error categories are essential. When downstream systems rely on Claude, the response must define a contract, not just a neat answer that looks right in a chat window, not just once during a scripted test. The sixth trap is treating MCP and tools as a catalog. A tool is part of the reasoning interface. Bad descriptions lead to wrong calls. Vague parameter cause unsafe guesses. Missing error semantics result in brittle retries. Strong tool design tells Claude when to use the tool. It defines what inputs are legal. It clarifies how failure should be interpreted. It guides retrying, escalating, or stopping. The seventh wrong answer is collapsing everything into one context window. More context isn't automatically more truth. Long histories can bury current instructions. They can leak irrelevant data. They increase computational cost. Strong architectures separate durable memory. They separate retrieved knowledge. They separate session state. They separate temporary scratch space. Context should be curated, not hoarded. Attention is a budget, a liability, and a risk surface. The pattern is now clear. Wrong answers focus on apparent power. Correct answers prioritize controlled behavior. The winning architecture uses least privilege tools. It enforces explicit agent boundaries. Prompts are evaluated before execution. Outputs are structured and predictable. Memory is scoped and limited. Recovery paths are built in. Claude is powerful because the system is disciplined. The system is observable at all times. Constraints are intentional from the start. They are not added after failure in public. The future CCA mindset isn't about making Claude do more. It's about what Claude should be allowed to decide. That single question changes every answer. You stop picking features. You start designing operating constraints. The exam shifts from memorizing Claude. It focuses on proving you can ship trustworthy AI systems, systems that stay safe, useful, and auditable. When the demo ends and real operations begin,